The Tower of Hanoi is a disk-moving puzzle. The diagram shows 3 stakes, A, B, and C, with 2 disks on stake A. The goal is to move the disks onto stake C while keeping the disks in the same order as stake A. There are 2 conditions for moving disks. The first condition is that you can only move 1 disk at a time. Moving 1 disk like this is no problem. But you can't move 2 disks at the same time like the above diagram. The second condition is that you can't set a bigger disk on top of a smaller disk. Let's look at an example of actually moving the disks based on the above conditions. The smaller disk is on top, so we can move it to stake B. We move the bigger disk to stake C, moving the smaller disk to stake C. We finish our moves. We were able to confirm that reaching the goal is possible when there are 2 disks. What about when there are 3 disks? Let's ignore the biggest disk and think about how to move the remaining disks to stake B. If we move the remaining disks in the same general way as before when there were only 2 disks, we're able to move them to stake B. We move the biggest disk onto stake C. Then, using the same principles as before, we move the disks on stake B to C. Our moves are finished now. We were able to confirm that reaching the goal is also possible when there are 3 disks. Actually, it's possible for all disks to reach the goal in this game, no matter how many disks there are. Let's try proving this using mathematical induction. We were able to reach the goal when there was 1 disk. Let's assume that we can reach the goal when there are n disks. Let's think about moving n plus 1 disks. We will ignore the biggest disk. Based on our assumption that we're able to move n disks, we move n disks onto stake B. We move the biggest disk onto the stake C. We move the n disks on stake B to stake C. Our moves are completed now. Using mathematical induction, we proved that the goal can be reached with any number of disks. Let's try thinking about the solution to the Tower of Hanoi. When solving the Hanoi problem with n disks, you can use the solution from the Hanoi with n-1 disks. To solve the Hanoi with n-1 disks, you can use the solution from the Hanoi with n-2 disks, and so on, until there is only one final disk, bringing you to the solution recursively. The recursive mode of thinking is used in many algorithms, and such algorithms are called recursive algorithms. This concludes the explanation of Tower of Hanoi problem.